Have you ever felt completely paralyzed by a complex choice? You know, those situations where every single option has entirely different pros and cons, and a simple pro and con list just doesn't cut it anymore? Well, welcome to this explainer. Today, we're diving into PROMETHEE Explained. We'll be unpacking a highly rigorous, yet surprisingly accessible mathematical framework designed specifically to rescue modern decision-makers from analysis paralysis and bring some much-needed clarity to the chaos. So let's start by addressing a pretty hard reality of decision-making: the absolute, mythical perfect choice. It rarely ever exists. Out in the real world, we constantly face conflicting priorities. Think about the last really tough choice you had to make. You probably wanted the highest quality, but you also needed the lowest cost, right? You wanted the fastest deployment speed, but you absolutely couldn't compromise on top-tier security. Finding a structured mathematical way to navigate these inevitable compromises without just blindly relying on a gut feeling is exactly what we are going to master today. Here is our roadmap for this explainer. We're going to cover the complex decision dilemma, the core concepts of PROMETHEE, calculating preference flows, PROMETHEE I versus I, visualizing with the Gaia plane, and finally, advanced PROMETHEE extensions.
Okay, let's kick things off with Section 1, the complex decision dilemma, or finding the perfect car when criteria inevitably clash.
Imagine you're managing a major corporate fleet. You've got 5 different car models on the table, but the priorities clash instantly. Take the economic model. It saves you a fortune at just $15,000, but with a power rating of only 50, it's going to genuinely struggle out on the highway. On the flip side, you've got the sport model. It boasts incredible power, but it absolutely burns through your acquisition budget and your fuel allowance. The data reveals a hard, undeniable truth. No single car wins across the board. Every single vehicle has an Achilles heel. A calculated compromise isn't just a nice-to-have here, it's literally our only viable way forward.
Moving right into Section 2, Core Concepts of PROMETHEE. Let's decode this acronym and see how the framework actually solves our dilemma.
PROMETHEE stands for Preference Ranking Organization Method for Enriched Evaluation. Now, the crucial point to understand here is that PROMETHEE is what we call an outranking approach. So instead of just giving options arbitrary grades in a vacuum, like say scoring a test out of 100, it sets up a head-to-head tournament. Think of it exactly like a round-robin sports tournament. It systematically evaluates how much one specific action outranks another on a specific criterion, measuring it on a highly precise scale from 0 to 1. A score of 1 means absolute total preference for one option over its competitor, while a 0 means there's no preference at all. This whole tournament logic unfolds in 3 really digestible phases. First, it performs pairwise comparisons, literally triggering a head-to-head battle, matching every single option against every other option for every single criteria. Next, it calculates unicriterion flows, essentially figuring out the definitive winner for just one specific category, like finding the absolute undisputed champion of price or power. Finally, it aggregates all of those individual category winners into global flows, crowning the ultimate champion based on how they performed across all battles combined.
That brings us to Section 3, Calculating Preference Flows. Let's look under the hood at the actual engine powering this whole method.
These 2 flows, positive and negative, are the foundational calculations for determining the true strength of any choice in your dataset. Think of positive flows as an option's offensive strength, its outgoing power, measuring how much it totally dominates the other choices. Conversely, negative flows represent its defensive weaknesses, the incoming hits, measuring how much the other options dominate it. A truly formidable choice is going to have a heavily loaded positive flow and a heavily shielded, tiny negative flow. When you visualize these offensive and defensive flows stacked together, the story becomes crystal clear. The positive scores pile up high above the 0 line, showcasing the undeniable strengths of an option. Meanwhile, the negative flows drop below the 0 line, revealing the weaknesses dragging the overall viability down. For instance, a car like Touring B emerges as a massive contender here. Its positive flow towers above the rest, and its negative flow is tiny compared to the economic or sport models, which have these massive defensive weaknesses pulling their overall scores right into the danger zone.
To find the ultimate balance, we calculate the net flow, which is simply subtracting those negative defensive weaknesses from the positive offensive strengths. By mapping the negative, net, and positive flows side by side on a triple thermometer view, we create a very clear visual hierarchy. And here is the real genius part. Drawing lines between an option's scores on these thermometers acts as a built-in early warning system. If the connecting lines cross wildly between 2 options, it's a massive red flag, indicating incomparability. It tells us that one option isn't universally better than the other. They just excel at completely different things, and forcing a direct comparison between them might actually be a huge mistake.
And that idea of incomparability leads us perfectly into Section 4, PROMETHEE I versus II, partial versus complete rankings.
Depending on the demands of your organization, PROMETHEE can give you two distinct types of answers. PROMETHEE I provides a partial ranking. This is highly realistic for complex worlds because it respects conflict. If option A is amazing at price but terrible at speed, and option B is a speed demon that utterly destroys your budget, they might just be incomparable. PROMETHEE I accepts that reality and refuses to force a bad fit. However, sometimes a CEO demands a strict 1 to 10 list, when you absolutely must force a definitive ranking from best to worst. PROMETHEE II steps in, using those net flows we just calculated to force a complete ranking, mathematically eliminating any incomparabilities.
But look, just handing a dense spreadsheet of rankings to a boardroom isn't always enough to win an argument, is it? Because human decision-making is inherently visual, let's explore Section 5, visualizing with the Gaia plane, mapping our conflicts in 2D.
The Gaia plane is basically a two-dimensional battlefield map, and it is a massive strategic advantage of the PROMETHEE method. In this space, our car models are represented as points, or bullets, and our criteria are represented as arrows extending outward. The layout tells a really distinct story. If two car bullets are clustered close together, they are practically twins in their performance. But the real insight comes from those arrows. The direction they point visualizes the exact conflict between your criteria. If the price arrow points in the exact opposite direction of the power arrow, it visually and mathematically proves that those two criteria are highly conflicting in your specific dataset. You simply can't optimize both.
Now enter the decision stick. Think of your personal organizational priorities as a dynamic compass guiding this entire mathematical engine. If your strategy shifts, say you suddenly need to weigh comfort much higher than price, your internal compass literally shifts its direction on the map. PROMETHEE instantly recalculates everything, projecting the best compromise solution based entirely on the unique direction of your strategic true north. The higher an action projects onto that decision stick, the better the compromise it represents for your unique worldview.
Let's move to our final section, Advanced PROMETHEE Extensions. It is vital to recognize that this isn't just a toy for one person picking a fleet vehicle, it scales up flawlessly for massive enterprise applications.
Imagine a boardroom full of department heads, everyone fiercely defending their own budgets and priorities. Disagreement isn't just likely in that room, it's practically guaranteed. That is exactly where PROMETHEE GDSS, Group Decision Support Systems, comes into play. It allows everyone in that room to first act as an isolated individual decision maker before aggregating all of those heated preferences into one unified group ranking. It's an emotionally detached, mathematically fair way to build absolute consensus.
The process diffuses tension in two phases. In phase 1, every individual stakeholder acts in total isolation. They use PROMETHEE II to generate a complete ranking based strictly on their own departmental priorities. This feeds this system pure, uninfluenced preferences from stakeholder A, stakeholder B, and so on, without anyone getting talked over by the loudest voice in the room.
Then, phase 2 kicks in, and the framework performs a beautiful merging act. The system actually treats each decision-maker's individual phase 1 ranking as a brand new criterion. It takes all those competing human preferences and runs them right back through the PROMETHEE II engine one more time, mathematically balancing the conflicting viewpoints to establish a final, undeniable group consensus that everyone can trust.
Also, there are times when you don't actually need a massive ranking from 1 to 100, right? Sometimes you just need to sort things quickly into buckets. The flow sort extension does exactly this. It lets you rapidly categorize options, like assigning hundreds of job candidates to hire, hold, or reject buckets, by comparing them against predefined benchmark profiles. You just set the strict upper and lower limits for what a hire looks like, and FlowSort drops the candidates into the correct buckets based purely on their PROMETHEE scores.
PROMETHEE takes the messy, emotional reality of boardroom arguments and transforms it into a structured, visual, and highly logical roadmap. We started by acknowledging that the ideal choice rarely exists, but as we've seen, the optimal compromise is always hiding in the data if you know exactly how to map it. So the next time you face a high-stakes group decision with completely clashing priorities, will you just rely on a coin toss, or will you let the math reveal the winner? Thanks for joining this explainer and enjoy putting these tools to work.